Hello friends, today's question. A ring and a disc are initially at rest, side by side, at the top of an inclined plane which makes an angle 60 degrees with the horizontal. They start to roll without slipping at the same instant of time along the shortest path. If the time difference between their reaching the ground is 2 minus square root of 3 divided by square root of 10 seconds, then the height of the top of the inclined plane in meter is. So in this case, we are given that there is an inclined plane and the angle of inclination is given as 60 degree, and here there are two objects, one is ring, another one is disc, and they start to roll. Let us suppose we draw only one and we will discuss both simultaneously. So it roll downwards without slipping and simultaneously, and the ring, the time difference when they reach this point is given as 2 minus square root of 3 divided by square root of 10. Okay. So it is said that it is going to roll without slipping. So therefore, let us draw various forces which will be acting on this body, and this body will be ring at first instant and the same will be disc in the second instant. But basic, you can see all the forces that will be acting with the same for ring as well as disc. So first of all, we are going to have mg in the downward direction, and which can be divided into two components. This will be theta. So we are going to have mg cos theta, and this will be our mg sin theta. And let us suppose the height of the top is given as h, and this distance which is travel, the ring and disc travel, is suppose is given as s. So s is the distance of the inclined plane from top to the bottom, and there will be a frictional force which will be acting in upward direction Fr, and because of this there will be angular acceleration alpha, and we can also assume that the angle of acceleration of the center of mass is AC, and which will be also in the downward direction. So AC is the acceleration of the center of mass, and alpha is the angular acceleration because of the force, frictional force Fr. So these are the forces which will be acting on the disc as well as ring. So in this case, we are first of all going to use, in order to find out, you can say, height, we are going to find out the distance s, and then we are going to use the sine of 60, which is going to give us relationship between h and s. From that we are going to get h. So for this kinematics formula which we are going to use is ut plus half h square, that a is the acceleration of the center of gravity, that is AC. So let us first of all find out what will be the AC for the ring as well as the disc. Okay. So we can say for the translation motion, mass into acceleration, that is AC, will be equal to mg sin theta minus the frictional force Fr. Let us call this equation number 1. For the rotational motion, it is said that the objects, both ring and disk, are rolling without slipping. You can say for rolling without slipping, the frictional force Fr results in the, we can say, causes the rotational motion with angular acceleration alpha, with angular acceleration alpha. Therefore, we can say that the torque about center of mass because of Fr, the torque about center of mass due to Fr, which is a frictional force, and that will be given as tau is equal to Fr multiplied by r, that is a radius, and which will be equal to Ic multiplied by alpha, where Ic is the moment of inertia of the disk as well as ring, whichever object we are going to take. And also for pure rotational motion, or you can say for rolling without slipping, our acceleration of the center of mass will be equal to angular acceleration multiplied by radius r. So substituting value of alpha, so we can say from here alpha is equal to AC upon r. So substituting the value of alpha in this equation, we get Fc upon r is equal to Ic multiplied by AC into r. And from here we can write that our frictional force Fr will be equal to Ic multiplied by AC divided by r square. So substituting this value of frictional force in equation 1. So if we can say from equation 1, we get mass into acceleration, that is just center of mass acceleration, will be equal to mg sine of theta minus, we get this as Ic AC divided by r square. So combining AC to one side, taking AC as common, we have mass plus Ic upon r square is equal to mg sine of theta. And from here we can say our AC will be equal to mg sine of theta, and this will be m plus Ic upon r square, and which can be also written as g sine of theta 1 plus Ic upon mr square. Now we are going to write that this is a general formula which is applicable for the disk as well as the ring. Only difference will be that the moment of inertia, that is Ic. So let us first of all write it for ring. So we can say for ring we have IC will be equal to I ring, and which is equal to mr square. So we can say that center of mass acceleration for the ring will be equal to g sine of theta 1 plus mr square divided by mr square, and these two terms cancel out, and this becomes equal to 1 by 2 g sine of theta. So we got the center of mass acceleration for the ring. Similarly, we are going to write it for the disk. So you can say for disk, IC is equal to I disk, and which will be equal to half mr square. Therefore, we get IC for the disk will be equal to g sine of theta divided by 1 plus, and we have this is half mr square upon mr square, and here also mr square cancel with mr square, and we get this as g sine of theta divided by 1 plus 1 by 2. In this case, we get center of mass acceleration for the disk will be equal to, this will be 2 g sine of theta divided by 3. Now we are going to use the equation for the kinematics. Now from kinematics formula, you can say that S is equal to ut plus half at square. So in this case, this is height h and this is s distance, and this is angle theta. So we can say our S is equal to h sine of theta. So first of all, we are going to write this kinematics formula for the ring. You can say for ring, T is equal to T1. So we get this as S, and it is going to start from the rest, so U is equal to 0. So you can say our H sine of theta is equal to half, and this is our AC ring into T1 square. So therefore, we write it as H sine of theta is equal to substituting value of AC ring, which is our half G sine of theta and T1 square, and which comes as equal to 1 by 4 G sine of theta T1 square. So from here on, we can find out our T1. So we can say our T1 square is equal to, this becomes as 4H divided by G sine square of theta, and value of theta is equal to 60 degrees. This theta is equal to 60 degrees. So this gives us that T1 is equal to square root of 4H divided by G sine square of theta. Now substituting value of theta, we can write this will be equal to square root of 4H, and this becomes G, sorry, it is square, and we get sine square 60. Therefore, T1 will be equal to square root of 16h divided by 3g. So this is the time taken by the disk to reach from the top to the ground. You can see this is the time taken by the ring, sorry, not disk, by the ring to reach the ground from the top. Similarly, we are going to solve it for disk also. So we say that same formula, kinematics formula, we are going to write it for the disk. So we can say for disk, let us suppose T is equal to T2. So once again, we get H is S is equal to, we have U T2 plus half AC for the disk, and here comes T2 square. Once again, U is 0, so this becomes half A of disk is coming as 2 by 3 G sine of theta, and this becomes T2 square. S is our, okay, this 2 goes by 2, S is our H sine theta, so we can say H sine of theta is equal to 1 by, this will be equal to G sine of theta divided by, 1 second, let me, yeah, it's 2 by 3, and this becomes 3 multiplied by T2 square. So from here we can find out that our T2 square is equal to, this comes 3h upon G sine square of theta, substituting value of theta as 60 degree. So we get T2 is equal to 3h G sine square of 60 and its square root, and this comes as equal to 4h upon G and its square root. So this is the time taken by the disk to reach the ground from the top. This is the time taken by the disk to reach ground from top. And in the question it is given that the difference, that is T1 minus T2, is 2 square root of 3 divided by square root of 10. So you can say, but the time difference is equal to 2 minus square root of 3 divided by square root of 10. So we can say that T1 minus T2 is equal to 2 minus square root of 3 divided by square root of 10. Substituting value of T1 T2, we get 16h divided by 3g minus square root of 4h upon g is equal to 2 minus square root of 3 divided by square root of 10. So from here we can take common as h, square root of h, as well as square root of g. So we get this as square root of h divided by square root of g, and this becomes square root of 16 minus divided by square root of 3 and square root of 4 is equal to 2 minus square root of 3 divided by square root of 10. Now value of g is said to be taken as 10, so this becomes as equal to, next page, So this comes as square root of h divided by square root of 10, and square root of 60 is 4 divided by 3 minus 2, and this becomes equal to 2 square root of 3 divided by 10. Sorry, it's square root. And here 10 cancels with 10, and taking 2 as common, so we are left with 2 square root of h, and here taking square root of 3 as common, so this comes 2 square root of 3 divided by square root of 3 is equal to 2 minus square root of 3. So therefore these and these cancels out, so we get here square root of h is equal to square root of 3 divided by 2. Square, not quite simple. We can say h is equal to 3 by 4, and this comes at 0.75 meters. So this is the height of the top of the inclined plane. This is the height of the top of the inclined plane, okay. Which basically means that this was given as 60 degree, and from here both disk and ring are simultaneously rolling, and this is our height h, which comes as 0.75 meters, and the distance they are going to travel is our s, which we can also find because we know already h. Okay, s is our, we already know relationship between s and h because we know the angle of 60 degree. So therefore this completes the question. Thank you.